Hello, everybody. Um, I wanted to give you a little guide to a tool that I've just introduced here for our module, our second module here in this course. Has to do with the loanable funds model. Now, you've gotten plenty of background of loanable on the loanable funds. You can go to my textbook, for example, and you could look at Chapter 8, Part 8.3. Chapter 8 is all about investment, and then in 8.3, we bring everything together in terms of the loanable funds, or ultimately you get a perfectly good treatment there in the 10th edition of Mankiw, pages 66 to 68. I'm indifferent between the treatments. They're both good treatments. But here we had this is sort of a let's say an animation of the loanable funds model. So you'll see here in this main graph, the downward sloping blue line is the investment function. We have the interest rate on the vertical axis, and we have savings and investment in percent of GDP on the horizontal axis. So this downward sloping fund line tells us that when the interest rate rises, that reduces the number of positive net present value projects, it increases the cost of capital, and firms will accordingly cut back their planned capital expenditures. When the interest rate falls, that makes capital cheaper, and firms will increase. They will increase their capital expenditures. That is to say, their investment expenditures, the accumulation of new capital assets. You'll notice here that we also have an orange line, which in this case is invariant to the interest rate. It's a vertical line, and this tells us the amount of savings that takes place. And you'll see that we're here at about 17.5% of GDP savings in sort of the normal case. And you may remember that this is that savings and investment in a closed economy, domestic savings and domestic investment are identically equal to one another. And how do we know that? And we should mention also that this is the interest rate at which savings and investment, i.e. the demand for loanable funds, the market for loanable funds clears right here. And okay, how do we know that? I'm going to refer you actually to another chart that I have, if I may, and this is in my book, and I'm just flipping into my book. So here in the book, you will find that this is figure 8.9, and I've shown this in other places, but the idea here is that this is, here we have a version of the model, and you'll also see this in Mankiw, where actually you have more savings when the interest rate rises. So the idea is that when the interest rate rises, that provides an incentive for households to cut back on their consumption today, because consumption is now more expensive. The rate of interest on their credit cards is more expensive. It's higher, and instead they'll put more money, let's say, in a savings account, and they'll enjoy that savings in the future. So here, we have the case where the savings rate increases when the interest rate rises, and the investment function is as before. Investment decreases when the interest rate rises. So the idea is this, as I said, that the interest rate that clears the loanable funds model is that where investment is equal to savings. And how do we know that? Let us suppose that the interest rate were higher. That would mean that savings would exceed investment. That would mean that you would have a lot of savers supplying funds, and they'd be competing with one another, and they would be driving the interest rate down. And as that happened, more and more investors, firms would be coming into the market for loanable funds. More and more projects would be coming online. The quantity of investment would be increasing. Simultaneously, you would be seeing some decrease in the quantity of savings as a result of interest rate falling until finally you reach this equilibrium. Let's approach it from the other direction. Let us suppose that the interest rate was lower than the equilibrium. That means you would be the demand for investment would be greater than the supply of savings. And what would that mean? That would mean that investors would be competing with one another for this amount of savings, and they would be they would be bidding up the interest rate. And as they bid up the interest rate, more and more households would be at the margin providing incrementally more and more savings until you reached this this equilibrium. So that's how we see the equilibrium. So, and you can see that, as I said, in either of the books. So now we have a little tool. We can talk about what happens, for example. Let's say, for example, if we have an increase in investment demand. Why would you have an increase in investment demand? Suppose that you have some new technological innovation and that things are a little bit more productive, and that means you want to acquire more capital in developing countries. What this often means is that you have some sort of reform policies, policy reforms, or reduction in taxes, or it could be some deregulation, the abolition of obsolete regulations. You get an increase in investment, and guess what? You will have an increase in the marginal product of capital, and that drives the interest rate up. Okay, I'm not going to go through other examples. Here you can see now you can change the assumption, and this is in your memo. So you have either no response or a positive response, and then you can talk about the question that you're going to be asked is what happens if you have a higher budget deficit, higher government budget deficit, because we're taking into account the fact that domestic savings is equal to private savings plus public savings. So anyway, you may use this tool when you do your memo assignment, but what we'll be looking for you in that memo assignment is your explanation, and we're not providing really an explanation here for you. We're just providing the shifts in the lines. So thank you very much, and good luck on your memo assignment.